So moving into adding and subtracting rationals that have unlike denominators, we do have an added level of complexity here. The first thing we need to do is create a common denominator. So for the time being, I'm going to block off the non-permissible values that have been listed and just deal with the function itself. The non-permissible values don't affect what we have to do, but they are still important there. So we have 2x over xy plus 4 over x squared minus 3, and for the time being I'm going to put it as 3 over 1. We will need to create a common denominator, and that 3 over 1 is just going to be a step we'll need to take anyways. So looking at the denominators, we can deal with this in terms of our coefficients, the numbers in front, as well as the variables. So each of these xy and x squared has a coefficient of 1. So in terms of our common denominator, we would need a 1. Looking at our variables, we have x and x squared. Highest exponent is x squared, so we would need x squared. Looking at the y's, we have a y here, no y here, and no y here. We do still need to add a y into the common denominator. Even though it doesn't appear in all of them, we do need to account for it because it appears in at least one. So a common denominator is x squared y. We need to determine what to multiply each of these fractions by to create that. So in this first one, our denominator is xy. We would need to take and multiply by x. I will try to do that a little bit nicer. We need to multiply by x on the top and the bottom, as always with making a common denominator, to move that to x squared y. This next one, denominator is right now x squared. We would need to multiply by y on the top and the bottom to create a common denominator of x squared y. And our last fraction only has a denominator of 1. So in order to make the x squared y common denominator, we'll need to multiply by x squared y. Multiplying this out, 2x times x is 2x squared. xy times x on the bottom will give us x squared y. Next one, we have 4 times y gives us 4y. On the bottom, x squared times y gives us x squared y. Last one, 3 times x squared y gives us 3x squared y over also x squared y. Now that we have a common denominator, we can go straight back to the same process we dealt with in the last example when a common denominator was given. We will end up with 2x squared plus 4y minus 3x squared y all over x squared y. Now we can't cancel anything yet. You may be looking at this and seeing, oh, I have x squared and x squared and x squared. No, we cannot cancel those because they're the parts of terms. They're being added or subtracted. We can only cancel things that are factored and have been factored out. So, as with the other ones, we need to look and see if we can factor anything out of the top. Well, coefficients, we have a 2, a 4, and a 3. Nothing is common. Variables, we do not have x or y present in every single term on the top. So there is nothing we can factor out of the top, nothing we can cancel. This is simplest form. Clear the page out to do question B. Again, non-permissible values were given. I'm just going to block those off. I'm going to let out the question again because we will need to get to a common denominator. But the change in B is, if you look at the first denominator, we have y squared minus 4. Anytime we have a multi-term denominator, we need to look and see if we can factor it. Y squared minus 4 is a difference of squares, so we can and we need to. Now, with adding and subtracting, we generally don't factor the top. It just adds a step that's not necessary when we get to combining like terms later on, so we won't even try, and this one in fact is not factorable. Y squared minus 4 factors into y plus 2 and y minus 2. Second fraction, we have y minus 2 over y plus 2, and y plus 2 is not factorable. Now that we've factored out, we need to create the common denominator, which will be slightly more complex than example A, but the same process. We need to ensure that we have every single factor present. So if we look, we have y plus 2 appearing in both, so we will need y plus 2 as a part of the common denominator. We have y minus 2 appearing here, so we will need y minus 2 as a part of the common denominator. We have nothing else unaccounted for, so this will be a common denominator. To create it, looking at this first rational, we have y plus 2 and y minus 2 in the denominator already. It already contains the common denominator. There's nothing we need to do to create it. On the right, we have y plus 2 in the denominator, but we do not have the y minus 2 that we need, so we'll multiply top and bottom by y minus 2. I'm not going to jump into combining these fractions together just yet, because there is one other added level of complexity we need to take into account. So the first one, we didn't need to touch it. It already had the common denominator. But the second one did not. We had to multiply by y minus 2. And the customary thing to do with adding and subtracting is to actually multiply out the top. So we will need to FOIL y times y, y times negative 2, negative 2 times y, and negative 2 times negative 2, which will give us y squared minus 2y minus 2y again plus 4 all over y plus 2, y minus 2. At this point now, we can combine these into one function. So we have y squared minus 20 plus y squared. I'm going to take those minus 2y's, combine those like terms right now, all over y plus 2, y minus 2. Now I did put brackets around the y squared minus 4y plus 4. When we were subtracting, it was absolutely necessary to distribute the minus in. Here it actually was not, because when you distribute a plus in, it doesn't change anything. Combine like terms, we have y squared plus y squared would be 2y squared. We have minus 4y, and we end with minus 16, which is all over y plus 2y minus 2. Again, look to simplify what we can. I'm just going to have to make a blank page here. I'm just going to copy the question down again at the top. So we have 2y squared minus 4y minus 16 over y plus 2y minus 2. Looking at this as a trinomial right now is not the best way to go. We have 2y squared, so we should look and see if we can factor anything out that's common. There is a 2 that's common. We can take out of the top, left over with y squared minus 2y minus 8 over y plus 2y minus 2. Looking now at that trinomial in brackets, do we have two numbers that both multiply to negative 8 and also add to negative 2? Yes. That would be y minus 4 and y plus 2. Again, still over y plus 2, y minus 2. Now that we're fully factored, we can look at things to cancel. We have y minus 2, sorry, y plus 2. Again, we cannot cancel this 2 with this 2 because this 2 on the bottom is part of a factor. We would have to cancel the whole y minus 2. Likewise, we can't cancel the 4 in the 2. We can't cancel the individual y's. So this is all the canceling we can do, which means we're left with 2 times y minus 4 on top over y minus 2. And again, because we're down to one factor in the bottom, brackets are not necessary, so that's why they've been left out.